Hello all, I am here to present about my project diabetes prediction using machine learning. So diabetes is among critical disease and a lot of people are suffering from this disease. Age, obesity, lack of exercise, hereditary diabetes, lifestyle, bad diet and high BP leads to diabetes. People having diabetes have high risk of disease like heart attack, kidney disease, stroke, eye problem, etc. Current practice in hospital is to collect required information for diabetes diagnosis through tests. The appropriate treatment is provided based on diagnosis. So, data analysis plays an important role in healthcare industries. Healthcare industries have large amount of databases. Using data analysis, one can study huge data set and find hidden informations, hidden patterns to discover knowledge from the data and predict outcome accordingly. In this project, the classification and prediction accuracy is little bit low. So I have in this model for classification of diabetes, which includes few factors like glucose, BMI, age, insulin, etc. Classification accuracy is boosted with the new number of data sets to further increase this accuracy. So next we will see about the. So this is the data set I have collected from the net, which includes the important um, diabetes determining factors like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and diabetes pedigree chart, and age. So using these factors, we can build a model and we can predict whether the person has diabetics or not. So now we will see about the backend of our project. So first we want to import the required libraries for this project. First I import pandas, which is used to load the data in the form of a CSV file. Next I import matplot library, which is used for plotting, and cbon, which is also used for plotting. And next I import sklearn, which is the powerful tool for machine learning, and it is also used to uh, statistical modeling like classification and regression process. First, I will import test split, which is used to train and test the model. And next, I import logistic regression. Logistic regression means it is used to predict a dependent data variable by analyzing the relationship between one or more existing independent variables. So next I will import accuracy score. So it is used to predict accuracy of our model. So next step, I am going to get the data from my computer. So I use this path to get the data from my PC. So if I enter data, I will get this data, which is I already shown before in the Excel sheet. But in this we didn't have all the data. Some data are missing. So 0 1 2 3 4, and then it goes to 6 763 like. So in order to get all the data, I use heat map. So this heat map will get all our data in the form of graph. So now you can see that a map is blank, so no null values are there, our data is fine. So next we're going to do correlation. The main purpose of using this correlation is to find that which column the value of our result is dependent. For example, we got a lot of columns in our data, but in this case we have only have 8 columns, that is 8 independent columns. But maybe we have a situation of using n number of column, but in that case um, we want to put all our columns into a model, so that that model will not produce the correct accurate outcome. So in order to find the column which are relevant which are not relevant, we are using correlation. So I enter correlation, I correlate the data which I imported and I print this. You can see that the correlation between age and the glucose is 0.263514, but in this also we can see that the more data are missing. So I use heat map to get all our data. So you can see that the correlation between age and skin thickness is around zero point 0.0, and age and BMI is around 0.2. So for our project we want only the output column, that is this outcome column. We want to concentrate on this column. So this is the output column which depends upon this 8 inputs. You can see that the output the output and correlation between output and glucose is more like around 0.5 to 6. So if, from this we can know that the glucose is the main dependent variable for this outcome, and we can see that uh, the correlation between outcome and blood pressure is around 0.01 or zero point 0.0. So from that we can state that the blood pressure is not much needed for this model, but in this project we are using just 8 inputs, so we are not uh, we are not taking out any inputs. We are using all the 8 inputs for training and testing our model. So next we will do the train test split up. For this we are introducing two variables called x and y. X is the input dependent variables, like all the input values like glucose, BMI, etc. And we want to remove this output variable, outcome variable from the input because it is the output value. And next in y we are using the output, that is called the outcome variable. So next we want to split this data. For this we introducing 4 different variables called x train, x test, y train, y test, which is equal to train test split. That is the library we are already installed, and the parameters are x, y, the two inputs, input and output, and the text size is 0.2. That means 20% of our data is presented in test section and 80% of data is used in train section. So if we want to know, let us enter x train. So we have got this x, we have got this training variables. We will see that in this we have only 614 rows. In the previous we have around 768 node, so 768 rows. So in this we can found that only 80% of data is used in train. So that's all. We are splitted test and train. So our training data is ready. So we train the model. For that we are using a logistic regression library. In the logistic regression library is inserted into the model variable, and next model.fit x train y train, we are fitting the x train and y train data into our model. So this performs the training and so next we move to prediction. We create a variable called prediction, uh, predict model.predict, which is the variable which are already imported predict variable, and we are going to predict the x text variable, and we want to print this predictions. We in this, some of the prediction is correct, some of them are not correct, so that we are going for next step called accuracy dot underscore score, which is the library which are already we imported previously. In that we are giving two parameters called prediction and y test. Prediction is the output variable which are got previous from training our model, and after that we are got this output prediction. And y test is the actual data which we get this from net, and we are going to comparing these two, and it will produce the accuracy value. From we can see that 0.7987, that is around 80 percentage of our prediction data are matches with the data which are already we imported from our source. So in order to increase the accuracy rate of this model, we will want to increase the train test ratio. That is this train test, if we increase this train test ratio, we will get more accurate, or otherwise we want to normalize our data. And another one solution is that we are using logistic regression, but instead of this, if we use other training modeling techniques, we will get more accuracy. For this project I have used this 80% accuracy. So next we will see about the front end. So this is the front end of our project. So this is the front end of the home page. In this I have used HTML, CSS and Java coding for developing this home page. And next is this predict page. In this page we are giving the input values like glucose, BMI, pedigree function values, age, and if we give that value, it will shows the output in the same page. So I have used this code. So now we will see working of our project. This is my website. So we can see that welcome to diabetes prediction system. Now let's get started. So we want to enter this details to get our output. First, number of pregnancies for women. If you want to enter for women, this is this column is needed. I enter 0. Glucose level, I enter 177. Blood pressure, I will enter 87. Skin thickness, I enter 50. Insulin, I enter around 230. BMI, I enter 39. Diabetes pedigree function, I will enter 78. Age is around 50. So let us see the output. It shows this person as positive. So that's it. ஸோ ஃபைனல் கன்க்ளூஷன். ஸோ நான் எதுக்கோசரம் இந்த ப்ராஜெக்ட் பண்ணேன்னா, இப்போ வந்து நம்ம லேப்ஸ் அண்ட் ஹாஸ்பிட்டல்ஸ்னால் வந்து நிறைய டெஸ்ட் எடுப்பாங்க. நிறைய பிளட் டெஸ்ட்னால் எடுத்து ஒரு எதுனா குளுக்கோஸ் லெவல், ஸோ அந்த மாதிரி ஒரு பேராமீட்டர்ஸாக கண்டுபிடிச்சி அவங்க இந்த ரேஞ்சில் இருந்தால் இவங்களுக்கு டயபெட்டிஸ் இருக்குது. ஸோ அந்த மாதிரி ஒன்று அவங்க வந்து அனலைஸ் பண்ணுவாங்க. ஒரு டேட்டாவே எடுத்து அனலைஸ் பண்ணுவாங்க. ஒரு பேராமீட்டர் டேட்டா எடுத்து அனலைஸ் பண்ணுவாங்க. அதுக்கு பதிலாக தான் நான் வந்து இந்த மாடல் க்ரியேட் பண்ணியிருக்கேன். ஸோ இப்போ என்னென்னா, இப்போ நம்ம அந்த பேராமீட்டர்ஸ் எல்லாம் இதில் என்டர் பண்ணிட்டோன்னா, ஸோ ஒரு லேப் அசிஸ்டன்ட்டால் ஈஸியாக வந்து அவங்களால வந்து டயபெட்டிஸ் இருக்கா இல்லையான்னு ப்ரெடிக்ட் பண்ண முடியும். ஸோ அவங்களால எந்த மிஸ்டேக்கும் பண்ண முடியாது. ஸோ இப்போ நம்ம இதோட அக்யூரசி ரேட் 100% கொண்டு வந்தோம்னா, நம்ம வந்து இது எக்ஸாக்டாக ஒருத்தருக்கு வந்து டயபெட்டிஸ் இருக்கா இல்லையான்னு நம்ம ப்ரெடிக்ட் பண்ணலாம். ஸோ அதுக்கு வந்து நம்ம கரெக்டான பேராமீட்டர்ஸ் வந்து நம்ம யூஸ் பண்ணணும். எந்தெந்த பேராமீட்டர்னால் வந்து கரெக்டாக டயபெட்டிஸ்க்கு வந்து டிட்டர்மைன் பண்ணுதோ அதை நம்ம யூஸ் பண்ணால், நம்ம வந்து இந்த லேப் டெக்னீஷியன்ஸ்னால் வந்து இந்த வெப்சைட் யூஸ் பண்ணி ஒரு பர்சனுக்கு வந்து டயபெட்டிஸ் இருக்கா இல்லையான்னு தெரிஞ்சுக்கலாம். ஸோ அவங்களுக்கு வந்து மேனுவலாக பண்ணுறது பதிலாக இந்த மிஷின் லேர்னிங் யூஸ் பண்ணி பண்ணுறதுனால நிறைய ஹெல்ப்ஃபுல்லாக இருக்குது. ஸோ தட்ஸ் த மெயின் ஐடியா கான்செப்ட் ஆஃப் திஸ் ப்ராஜெக்ட். ஸோ தேங்க்யூ ஆல்.